So we're starting to build some more skills for creating interactive games. And one of the ones that's useful is to populate a world using a tile map. A tile map is where we will store information about each block or cell of our world map in a tile. This allows us to know what kind of item it is, whether it's a wall, a tree, a hole, floor, ground, water, and then we can place our game objects, our player, our enemy, and things like that into this world. So in this example, we're just going to look at how to construct a simple tile map with our project. So I'm starting out on this one, and I will set up my size. This time, instead of 800 by 600, I'm going to go 640 by 640. So we're going to make a square game world. So as we're going to work with this world, we need to create our map. Now our map is stored as an array of numbers. So we're going to just store numbers, and the numbers will correspond to what's in our map. So with that, we're going to let a 1 is going to be a wall, and 2 is going to be floor. So then we're going to draw it. Now to do that, we'll create a two-dimensional array. So this means we have an array that's populated with other arrays. So the way to think about that is, if I think about making a single map row, that map row could be set up as an array when we're working on this. And we can populate it. So we can populate it by putting it in curly braces. So we're not doing a dynamic array like when we had an array of objects that we're populating with the loop. This time we're going to actually type it in. So if I type 1, so if our first row, I just want to be I have to get my keys pressing correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 items. So I want it to be all walls. So if we do this, okay, that's how we can do it. Now I want to do 10 columns, and I want to make it 10 rows. So we could do, individual map rows and then putting them all together, but the easy way to do it is to create a two-dimensional array. So it looks like this. So int, then we just do, well, not curly braces, square bracket, and I'll just say is tile map. And now this time, when we make the tile map, we're going to set it equal to, and we do a curly brace, we'll do a couple returns and another curly brace. Now inside of it, what we want to do is we need 10 rows. So I need something like this to be my first row. And at the end of the first row, I'll just put a comma. And now I'm going to go, I want to have a wall. And now we'll just have a series of floor pieces. And in this version, when we are going to render or display our map on screen, what we're going to do is simply draw rectangles where we want to see each, whether it's a wall or floor, and then they will be filled with different colors so that it kind of makes sense as to what's happening. So I've created the first 2 rows. Now that's my 3rd row, 4th, 5th, 6th, 7th, 8th, 9th. And now my 10th row is going to look like my first one. So I'm trying to just create a simple kind of box-shaped item. Now the last one, we don't have a comma after it, and once I get rid of that, then we should be in good shape there. I just have to now put a semicolon at the end here, and the red underline went away. So we need a semicolon at the end of our item. So we could put all of this on one line, but it looks a little bit easier, or a little bit better. It's easier to see what is happening. So I have all these zeros in the middle, and then I have ones on the perimeter. And I could even just put some random ones inside here, like this. Now, if you're thinking, it's like, wow, this is a lot of work to try and plan this out. Well, there are programs that can help you with generating tile maps. So that is something that if you progress, you may want to look into. Now, we will need to store a couple values as we work with our project. We're going to need to hold the number of rows and the number of columns inside variables, because we'll be referring to that in a lot of our code later on. And then we need our cell width and our cell height. So we need those 4 values as well. To calculate them, to generate these values as we work with it, what we need to do is, well, cell width is easy. Then we're going to set our cells equal to 64. Our game objects, our player, enemy, they're at 32, so that they're a little bit smaller. You could have everything the same size. I just find in a lot of instances it just works better this way. So we've set up our width and height. Now if we want to do things in order, rows and columns should have come first. So if I count how many numbers I put into each row, that is how many columns I have. If I count how many rows I have, that is now going to tell me how many rows are in my array, so we can generate those values. So we could count them and say 10. Rows is equal to 10. Calls is equal to 10. But these are arrays, so we could also just dynamically ask for that. I could just simply say rows is equal to, on this, the length of my tile map array, because how many rows do we have? Well, that tile map has 1, 2, 3, it's got 10. Like that. And I could also say columns is now equal to tile map, and that accesses the first array. To access an element within this, well, we use our array notation, which we've learned previously. So I'm just going to go grab out of the first one, and this is going to tell me how many columns by counting how many items are in this array, because we look at these numbers. I mean, we have rows and columns visible on screen. So you have a column here. These are columns, these are rows. So how many columns do we have? Well, we can count it. How many rows do we have? We can count it. So we could dynamically be grabbing these values like this, or we could have counted and known that it's 10. If I wanted to make my map bigger, I would have to change those from 10 to something else. So hard coding is okay on something small like this, but if you have a much bigger tile map, so it's 100 or something, or it's uneven, you're playing with a non-square world, well, in that case, it's easier to just dynamically grab the values, and we don't have to worry about whether I make this bigger or smaller, because generally a 10 by 10, it's a pretty small game world. Now if I run this, we'll see nothing shows up on screen and nothing broke. So it's a good idea, now that I've kind of completed my setup, to run it before we start trying to draw the map on screen. And that's what we will do here. Let's just go and bump this up a little bit. What we want to do is, I want to say background, and I'll just go 120, nice light gray, and then I will, after that, call a function, render map. Now we haven't defined render map yet, so of course we're getting an error message. So if I want to render that map, let's do that. And we put a little comment on there so we know what is happening. So now comes the fun part of we get to render this out. And the way that we do this is we are going to go through each row. So we'll say, okay, first row, I want to render out each column. Boom, 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 boom. And then next row, I want to render out each column. Boom, 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 boom. So it really does draw it in the square, or number order that you see here. It does a row, and then it does a column, and then it does a row, and then it does a column. And with this, then we're going to fill it in based on where this is. We know how big we want each item to be on screen, so each cell, we know what size we want it, so now we're going to be able to draw it. So for this, we have to do a for loop inside of a for loop. So we're going to go through and say, okay, grab the first row. So that's going to be my first for loop. So I'll say for int I is equal to 0, I is less than the number of rows, and then I plus plus. So it's a standard for loop like what we've used before. And then I'll just put in my statement there. And now, while we're doing each row, then we're going to have a second for loop. So this is going to be for, and not I, but this time we'll say j is equal to 0. So we just go up in the letters, I, j. So we're just going up our alphabet here. This is a common thing to do when coding. Now, not I, j, and it's really easy while you're doing this to mix up your i's and j's, and then your code doesn't perform quite right. So just, you've been warned. Okay, so now we've ended that. And what we need to do is we want to display based on accessing a particular square. So remembering that we accessed a row, but when we're accessing now a particular row right here, which then we can count how many are in it, we use a single thing to say I wanted to access the first row. We use the square bracket notation. And we'll use the double square bracket notation, just like the Tilemap uses double square brackets to say it's a two-dimensional array. And if this is the first time you're seeing this and you may be like, okay, my head's kind of hurting here because this is really weird syntax as I work with it. Yeah, it is. It takes a little bit of getting used to. I am going to use the switch statement here because I do think it makes it easier and our code is cleaner with less curly braces than if I were to use if-else-if statement. So I will say switch. And then what am I switching on? And well, I'm going to be switching on whatever the value is inside that particular cell of my tile map. So I'll say tile map, and then we just go square bracket I, saying I'm grabbing the, not curly brace, square bracket I, because I'm grabbing the first row, and then I want to grab then the first item within that row, or a column, so then that's J. So we use this double notation, or double square bracket notation as a way of accessing it. And then finally, this is my end switch. When we have, in this case, as you can see, 4 curly braces lining up, you really do want to put these closing comments on it to make sure you, one, have all the curly braces, and two, you know what they belong to. Otherwise, you're going to find yourself really unhappy as you work with it. So now I'll say case, and what we have in this case, what do we have? One case we have is 0. Oh, case, the value, and then a colon. Sorry, case, then value, the colon. And now, with that, we're going to fill our walls. I'll fill it with the dark gray, so I'll just say 80 at that point. So that now creates a dark gray fill color. And then I want to draw a rectangle. The rectangle, where do I want to draw it on screen? Well, this is where we get to have fun calculating where to go. So we know that it starts out, so each column here, columns correspond to x's, rows correspond to y's. So each column as we work with it is tied into j, because we look at the for loop, j less than columns. So we're going to take whatever j currently is, and this is going to give our x value, and we're going to multiply it by the width of a cell. And that gives us the x value. Now, the way to think about that, so this first one, well, j starts out at 0. 0 times 64 is still 0, so that puts that first cell, its left edge, its x value is at 0. Now, the next time I run this for loop with j is now 1. 1 times 64 will put my next square at 64. Go again, now I'm at 128. So on and so forth until I reach the end of the line. Now we calculate where our vertical is going to be by saying I times my cell height. Remembering that we're dealing with the rows. I starts out at 0. So 0 times cell height, 64, is still 0. The next time we go through it, when we move to the next row, I is now going to be 64, or I is going to be 1. 1 times 64 will be 64. So I'll put in the next one, then 128, etc., etc. Now I want to make each cell, when I draw it on screen, 64 by 64. Well, that was dumb. It's not 64 by 64. It's my cell width, cell height. I mean, I could hard code it in, but if I ever decide to modify my game and say make all my cells smaller because I want to fit more cells on screen and make a more complex world, I don't want to hard code values in. Okay, so we've put this in, and we now need our next case. And then case for 1. And this time we'll set our fill. So we're going to choose a color. So I'm going to find kind of a just a unoffensive green color here. 114, 188, 128. Gives me a green color. And because I'm just realizing one thing I want to do is I don't, well, no, we can leave that. We'll do it on each one. Let's copy that, paste it over. So it is the same line of code, so we probably should move it outside of the switch statement, but we're going to leave it in there for now. Now, switch statements, especially in something like this, which we want to make sure is not having any kind of breakdowns. When we're doing the keyboard thing, because we only cared about 4 keys and there's all kinds of other keys, we don't really need a default value. But here, as we work with this, we want a default because if something is broken in our code, I want to print out a message that says something is wrong with map, the map. That way, if we have something screwed up, so say when I created this, if one was like, short and it's trying to do it, then we'll be like, whoa, something broke on here. Or if we now have a value that's not being looked for, then that would cause a problem too. So now if we save this and run it, let's see, what do we get? We can see that it now filled in the squares. So we have all of our squares filled in, and we have the black lines showing us the grid because the default 1 pixel black stroke is on. But we can now see how this tile map with all these different numbers creates our game world that we're able to explore. And if I were to add in, now let's see if we put a different number in here. Now that square it's the default gray, not the other darker gray, and it gave me a message. Something went wrong with the map and it's grumpy. Okay, so that's why it's good to have that default in there. If I added to my map and made my world bigger, so right now it's 640, 64 times 10, but if we added on to this and made it 704, because then that would be 64 plus 640. So if we said 704 for width, actually I'm going to do it on height because then that'll be easier to add in. But if we just add in 704 here, so we have another row on it, and we'll just do a double wall at the bottom so we can see. Put a comma here. Now if we run it, we can see now we're able to extend our game world. Because we didn't hard code these numbers in, if we grow our map, the whole thing just grows. So as you work on your own projects, know that you have the ability to customize what you're doing. Now, so processing, it would be nice if we could define our size dynamically, but it doesn't want that. It wants us to define it in our first line. So that's important. But now that we have the ability to create a game world, our next step is to bring objects into this game world and to have them interact with this map and determine, are they interacting or trying to move into a wall tile versus a floor tiles. We want to restrict the movement of the entities in our world to specific kinds of tiles so that we have to stay on the floor, we can't go through walls, or if we can go through walls, maybe there's some kinds of walls. We could have interior walls you can go through, the perimeter walls no game objects can go through. So these are things we will look at in an upcoming video. So good luck and have fun.